So using the normal distribution where, in this case, the normal x approximates a normal distribution with a mean of 7, and 2.2 squared means that the variance is 2.2 squared and the standard deviation is 2.2. So when you sub into your z-score formula, which is the data value minus the mean divided by the standard deviation, you get for a value of 3 that the z-score is negative 1.82, and for a data value of 6, you get a z-score of negative 0.455. So going to our z-score table, the first one was negative 1.82. So go up to the negative. So negative 1.8, and then we got to go across to 2. And so here, it's approximately equal to the third 3.4 percentile. And the next one was negative 0.455. So we'll scroll down, and negative 0.45, and this column will be 5. And so it'll be partway between these two numbers because it's negative 4.55. So we'll say it is approximately at the 32.6 percentile, just as an estimate. So going back here, so this is the 3.4 percentile. And this is the 32.6 percentile. Now, we want to know what percent of the data is within these given intervals. So between the 32.6 percentile and the 3.4 percentile, the percentage of the population between those two values is going to be equal to 32.6% minus 3.4%, which is approximately equal to 29.2% of the population will be between 3 and 6. So going up to the next one, a couple things I'd like to point out at this point. If you have a value of 7 and the mean is 7, then your z-score is 0. And when we go to z-score 0, you get a value of 50%. And that makes sense because in a standard, in a normal distribution, a value at the mean represents the mean, median, and mode, which puts this at the 50th percentile. So this would represent the place, the spot on the normal curve where it's at its peak, the peak of the bell. And for 3.64, again, this is going to be off our z-score table. But if you look here, we're getting pretty close to 100%. So for all intents and purposes, anything over z-score 3 represents the 100th percentile, that there are very few data values up at that range. So this is the 100th percentile. And so this means that approximately, so 100 will be the value of the percentile for 15, and we're going to subtract 50%. So that means that half of the population, or 50% of the population, or the probability of selecting a fish within this range out of the lake, is 50%.